Hello everyone, we're back here again with me, Ganesh, the head of architecture of TypeDB, with James, ex-principal scientist at TypeDB, and finally Josh, which is the CTO of TypeDB. And today, as part of this podcast series, in which we've kind of talk about the things that we go through on a day-to-day basis, as well as mistakes and things that we think we're happy with. We're going to be today talking about something that I think, can say we know quite well of.
And we have a lot to say, so we're going to try to keep it tight.
Yes. And what it is? What is the topic that we're going to be talking about today?
Well, I would say that every programmer's favorite debate point is what is their favorite programming language.
Exactly.
And we have some things to say and what we think about them.
Yes. So back in the days, I think TypeDB used to be, well, not really back in the days, only a year ago, we were in Java, right? TypeDB was written in Java. And personally, I think I hadn't programmed in Java before joining this company, and I was a Scala guy before, functional Haskell kind of thing, functional language. And I do like language quite a lot. It had introduced me to a lot of things that I hadn't thought was possible, expressible in a programming language. So I quite like Scala. Coming in as a Scala guy and having to write Java, I did have some preconceived notion about the language before. I have to admit that Java is always associated with Spring Boot and things that are clunky and enterprisey, right? Which I didn't quite like at the beginning, but I had to do it, right? But I do say that I have, after working with the language for some time, I had a newfound appreciation for the language, because even though they're quite, I think, basic and minimal, they are actually quite well designed, and things actually falls together quite nicely.
And yeah, I would say Java has an excellent standard library. Java has really good language designers and implementers. And for instance, things like concurrent hash map that in Java is a built-in native feature and part of the standard library. Normally what Java implements, a log4j, those kind of systems, they get ported to other platforms and other languages because they're just so well designed.
Yeah. They inspire other languages.
Exactly. So it's just I'd say it's just really solid and robust, and it's a little verbose.
I didn't know you'd moved over from functional. How did you find that
exactly right
switch? I didn't know that.
Exactly.
That was because you joined a year before I did. So your brain was not there for object oriented at all, right?
I have been exposed to object oriented programming before.
I mean, who hasn't?
Yeah,
right? Everyone.
But it does feel like moving from a kind of a Ferrari to a Toyota. Well, things that used to exist don't exist now. There had been that feeling, yes. Yeah. But what's your take on it? Do you find Java pleasant to work with? Do you like doing factory equals to new factory?
No, I really didn't. I was, well, to be fair, I mean, I came in as Python. I came in fully because I was all about I got shunted into programming, right? Because I decided that AI was the coolest thing around.
Yeah.
In 2012.
Yeah.
And I started in MATLAB. That was my start to programming. There's something
global variables.
Let's say no more. Let's say no more.
Mutable.
And then and at that time the Python ecosystem had just picked up enough that you could actually then I had an algorithm to write before TypeDB, right? That I was trying to commercialize and build into a product, and that was a matter of then taking that MATLAB implementation and then figuring out how to get it into Python, because the Python libraries had kind of just got to a point there where you could the community with Python was really moving on choosing this is the language for us to do ML in. So first love was for Python, but you end up with quite a lot of mess.
Yeah.
Well, actually, I tell you what was really interesting was trying to learn, when I was learning in Python, I was trying to learn how to program well. Not a good language to learn how to program well in with Python, because you can do anything.
Yeah.
And because you can do anything, it's all
up to you.
It's all up to you, and very difficult, especially when I was a really nascent programmer. I would still say I probably am, to be honest. But you then the switch to Java was good. Meant that you didn't have that freedom, so that's good. Meant you had to learn a lot, but that was good. But I just found it was just missing this like consistency edge to it.
I see what you mean.
That particularly as someone who I didn't do a computer science degree, right?
Yeah.
Like I like to learn by doing, and learning by doing with Java wasn't necessarily perfect.
I do find the APIs, the standard libraries, sometimes have inconsistent library functions.
You had to help me a lot. Like I remember this. Like it was like not an easy road to just, and I got dumped into just like immediately doing the reasoner. I think that was basically the first thing, the reasoning engine.
Yeah.
That was quite a hardcore jump to just go from like
you were doing some serious
what
stuff.
you're doing to then suddenly doing that. And I think once you got to grips with it, then it had tools you could reach for, and
it's got a wide ecosystem, kind of like Python, but predating it in many different forms.
For building. I can see why people still want to use it to build big systems, because there's no question that you can get some big stuff done.
Yeah. And I think in terms of rigor and safety and stuff, you can get a lot from Java. Like you'll uncommonly get null pointers. Like you can get null pointers, but there are tools now, especially in the newer versions of Java, which borrow from functional land too. And they've extended Java quite well with streams, with options, lambdas. So I think Java has evolved well to help you cover some of its blind spots. And I find that quite interesting. And I find it less of a mess than, say, C++, for instance, which is a big fractured, I think, mess in my mind. But I think Java gives you structure. It gives you not the most pleasant working experience, but it's very like professional. It lets you do serious things.
I would credit that a lot of it comes down to their build systems, which is Maven. Oh my god, the XML declarations that we had to basically untangle.
That's a royal we.
Yeah,
all the build problems ended up on
boot up and build engineer.
Like
infrastructure.
These guys are working with like Reason and whatnot, and I end up having to work with the XML bits. But that was good. I think we were actually able to make it made a reasonably well architected software, I think, with Java. So that was like
around what time?
I think the 2.0 rewrite.
Yes.
2.0 rewrite.
So here, the one of the downsides of Java is you can also still make a mess if you're not very careful, and the build system lets you make a mess and stuff. One of those reasons is why this is a whole separate topic. We moved from Maven to Bazel is to help us put strict. Don't be circular.
You still use Bazel now, right?
We still use Bazel. Separate discussion point, I think. But Java, we basically rebuilt 1.0 to 2.0 for performance and fixing architecture with better structure and better ideas, and enforcing that through Bazel at the time, especially. And so you can still make a mess in Java. We wrote spaghetti code and had everything mixed into itself. But then 2.0 was well-structured Java, and that was quite a joy to use and extend, I would say. And you don't even have to follow, I didn't know this, you don't have to do the package structure that looks like com.typedb.core.server. You can just put it all in one root folder and everything will work. So a lot of the nuisances are convention, and you can choose to break them.
That's how we do things as well. Right?
That is how we do things. And I think ultimately a lot of people build big, fast systems in Java. One of the things that also prompted moving away from Java, I would say, was the fact that our underlying storage layer was in 2.0 RocksDB, which is an excellent large-scale key-value store that we used as our foundation layer instead of Cassandra and Janus Graph. And one of the problems is that you just always incur performance overhead when you're moving across the Java boundary into native code, because bytes get copied in and out, and there's there's just costs. And so that was one of the reasons we started looking for non-Java alternatives in the chase for more performance, getting rid of the garbage collection pauses. And so
I was going to say, I thought garbage collection was one of the big ones, particularly with data loads and this kind of thing. Garbage collection was really killing us.
A lot of things were noticeable, but I think we were basically looking for some good wins in performance and structuring it even better. And there was this new kid on the block, I would say, Rust, which was growing up by the time we were starting to think about moving away from Java in TypeDB 2.0, 2.25 I think we got to, or something, after 1 or 2 years of using Java for that. And going into 3.0, we knew we were moving away from Java. And I think for me, the reasons were large performance. There were a lot of philosophical reasons, which maybe you guys can talk about a little bit. And we wanted to use a systems language for systems engineering. So
Yeah.
that's the high level philosophy.
Yeah. Definitely. Like I think we've been able to gain some wins with Rust without having to pay the cost of memory safety, which is big, right? Our performance not only get faster, but also becomes
Fewer bugs.
more predictable with fewer bugs, fewer like NPEs and null pointer exceptions. And while the language is verbose, I think they're verbose for a reason. It's justifiably verbose. You definitely have to think a lot about ownership. I think I remember back then I was confused. Why would I have to make all the variables that I need to pass to another thread static? And apparently my thread wasn't scoped. So in theory, the thread could live longer than the main function, and therefore that's why the data that I pass in have to have a static lifetime, right? So we had to deal with a lot of those. But I think I'm quite happy with the fact that our program, our database is now like really competing with what's out there in terms of performance and predictability. And Rust is definitely quite a beautiful language with their own syntactical verbosity, I would say, but quite beautiful. Gets complicated when it gets down to like lifetime. These guys also have this guy has some experience,
some stories to tell.
Yes.
Even from his later entrepreneurial ventures, right? Some lessons as well.
Some lessons. Yeah, I mean, I actually started learning Rust while I was still at TypeDB, but I was just doing it in my spare time because we hadn't actually. We knew we were going to start moving, but we were still on 2.0.
And that's about the time you left, right?
It is. Yeah. Well, it kind of, for me, a lot of things happened at once there because, the reason I was interested in Rust in particular was because the foundational idea for Etchpad had already occurred to me while we were writing TypeDB 2.0.
Which is the product you're working on now.
Exactly. So that's the company we're starting now. Again, as per branding, company and products, it's currently called the same thing.
Etchpad.
And Etchpad, yeah. So, and that's all about, that's an interesting one in terms of the choice of Rust, but the crux of it was I was bashing my head against the table in Java, trying to build the reasoning engine. That's actually what I was going to ask you, but we'll come back to that in a sec, which is like modeling in Rust and the difference, because I found that the mental model, the modeling, we were trying to build a reasoning engine, which is basically like a functional execution engine, right? If you just simplify it to what it looks like today, in an actor model in Java with the ability for it to, it needs to accept like any kind of user data or that could come in, any kind of rule or function body that they've written, and that needs to be processed. And you and I spent a lot of long nights trying to figure out how to get this thing to work, how to get this system to work. And I found I was just beating my head on the desk thinking, this is just so difficult. I just can't keep in my head the three models that we have right now that we're trying to serve, like the domain model, the actor model, and Java, and how we've implemented all of those and where the threads are and what's happening in each, and all the concurrency problems we kind of made for ourselves with that. But it was obviously the natural and best solution to the problem, but was really hard. And that was really where I was thinking, my engineering-y brain, right? Because always I grew up with like a spatial brain rather than a computing brain, if you like, right? If you're going to try and distinguish the two, but very much like I wanted to play with Lego as a kid. I wanted to. It was physical. I thought I was going to go into mechanical engineering, and ended up in sort of AI and ML stuff. And I wanted the blueprint. I was like, where is the blueprint of this system? Because we ought to be able to have that, especially for Java, right? Like what the structure is.
Structured.
So that was where I started ideating on what Etchpad. I mean, I'm really not the first person to think I would like a diagram for this, but we're trying to take a good stab at actually how might that really realize itself. But when you start thinking about that, the moment I'm thinking about that, I'm thinking that's an interesting project because it's an application level UI style project in terms of what you're trying to show, but the speed, you're going to really need the speed to be able to operate over source code at the speed that you do. You need to work with tree sitter, you need to work with language servers, you need to work with all these things, and you need to make it needs to be really rapid. And that's when I really fell for Rust, because it drew together the kind of things I liked. It looked like Python. Right? Are you sure? Okay. Like if you look through slits, right? It has like a Python style of writing, the way I see it, right?
He's wearing his beer goggles.
Yeah. Well, crucially, if you remove the lifetimes, right, in particular, and it has like that kind of style. It looks after you. It holds your hand. Like the compiler is amazing for telling you
really, really tightly until you
it really holds your hand. Like, yes, like you must go this way. Yeah. And really safe, right? And giving you guidance coming back. And actually, what was really interesting for me at that time, the meta kind of experience on that was when ChatGPT first came out. And so I didn't just have the Rust docs to learn from, and I was trying to do a solo project as I'd left the company. I was going off and I was doing other things. ChatGPT 3.5, whatever it was that came out then, was amazing for learning Rust. It was really amazing because even though it was like wrong half the time, and you had to still, that kept you very, very much your frontal cortex still alive because you had to try and tell, is the advice that it's giving me correct or nonsense, right? Is it just it was hallucinating all the time. But it would at least, like, you could ask, okay, I just don't get why this can be true in Rust. Like, why does this need to be the case? You want to ask specific questions to like query your understanding, and you could literally ask those questions and get an answer back without trying to search around the Stack Overflow to look for something similar that's not the same, etc. So you could just ideate, and that was an incredible learning tool for picking up Rust at that time. Then I went on a bit of a journey with Rust UI frameworks, which has been a separate thing. I think I've rewritten that 4 times over the lifetime of the product.
Right.
So if you were to take what you're building now and use it back when we're building the reasoner, what would it do?
So the idea is ultimately that at a glance you can keep tabs of what all the components are that you have and zoom in to see the detail on any of those at any given time, right? So that you can actually get a crux of like, okay, what do I have? How do they interact? How many pieces of the puzzle do things interact with? And what are the knock-on effects of touching something? So basically we can stratify this into layers, and we can see like, okay, I have my and that was literally from inspired by working with you guys and everyone else at the company at the time, with Heiko, with Casper, with all the big brains we had, was talking about these different like levels of not just of abstraction. Actually, they don't directly.
True.
They're like not correct from a human perspective abstraction.
Yeah.
But in the code, not something which actually you're changing, whether it's public, package, private, or whatever, right? But what you're actually thinking of, and I thought that was a really interesting thing I picked up from working with the team here was. There's several soft things that are actually going on when you're coding that are really not recognized in the code. So what we're doing with Etchpad actually is kind of bringing them to the foreground. And I had a really nascent developer friend of mine have a look at this, and he was like, oh, I can see like my primary functions and secondary functions and tertiary functions doing this, right? Within a single file, for example, right? So you can see in your file, what does a storyline look like? Storyline actually is a very key word that I really picked up from when we were, I was learning a lot from working with the team, and that's really part of what we're trying to do. Showcase that, I mean that at a glance you can just like understand where you are, what's going on, what's changed, do I still have, that, all these kinds of questions.
And I think to pick up on the storyline keyword there, I think that is something that we trained ourselves and we're training each other in, and from Heiko and from Casper and to each other, is the idea that the story should be, that this code should be explainable to a human, which is why we are big fans of domain-driven design, for instance.
Yeah.
And you use human terminology to go through, and this component does this, and it interacts with this to do that. Oh, okay, these pieces are there, right?
Yeah.
And to understand that. And I think coming back around to Rust versus Java, you can do that quite well in Java. I think you can do it actually excellently in Java. You can do domain-driven design, you can do encapsulation, you can do private classes, you can hide things. All of those things are very well fleshed out. And in Rust, you can also do that. And it's a different way of thinking. But I think what Rust makes you do is it gives you that ability to write the story and then makes you structure it. Because you have to say, oh, this one is the exclusive owner of these 5 things.
Yeah.
Or these are shared, and the type system makes you think about those things. Yeah. So I think what I find Rust very interesting compared to Java is you're trying, as you're building a design in domain-driven way, as we like to do, you're building the story, and then Rust is like, think about this a little more, think about this a little more.
It's a pedant.
It's quite pedantic, and I think when you're building scalable systems, when you're building safety critical systems, when you're building for performance, or I think even I would nowadays pick it up for a medium-sized, smaller project just because I know I'll get it right the first time. It's really good to force you into a solid, understandable structure.
I think the meta structures in any kinds of environments, there are things that you need to abstract because they don't matter, but there are always constraints that you just cannot abstract away, right? So in Rust, there is just one more of that compared to Java, which is the fact that you have to ensure that the scope of the lifetime of the things that you're creating is well defined, which you don't have to do in Java.
Yeah, because Java will just garbage.
Same like in distributed systems, right? Like there, you just can't abstract away the fact that the other computer may crash, right? So yeah, I think that's kind of like the meta point. Is like it's always possible. I think I'm agreeing with you that domain-driven design is always possible in any language, in any environment.
But it's like, if you said that,
but harder, I think, and I think you only get so far with in Java. The way I see it, you have interfaces, but really you're working with composition and inheritance. The traits in Rust. This is what I then wanted to ask you about: is moving to, because you led the architecture development mostly on TypeDB 3, right, and that move over to Rust. How did you find, and I'm particularly asking this because there's an analogy for me between the trait-based modeling in Rust and the relational modeling in TypeQL.
Oh yeah,
right.
Fun.
So for me, what I was finding when we were writing TypeDB 2 in Java was the frustration over the fact that the programming language we were using was actually not as complete as the language we were implementing. But we couldn't use the language we were implementing because that's a database language to build the data,
certainly interesting.
Yeah.
I think so, yeah. You're talking about philosophy really in some ways here, and Rust's composition only design essentially. And what I find very beautiful about the trait system is the ability to parameterize generics and say like, this is automatically implemented for anything that has this other type, and then you can use that as a. I think that's very beautiful. So that's something we don't even have in TypeQL, and I can imagine how you would build it in TypeQL. So that's a fun thing we could do. Say there's an interface, and then you say anyone that has this interface has this other thing. So I find Rust's composition that way quite beautiful, and I think philosophically it does align quite well with TypeQL because we're also quite opinionated in building data models because we provided an opinionated language to structure your data in. You need to tell us what your relations are. You need to tell us how they relate by roles. You need to tell us how many times can you own this attribute. And I think that's very reminiscent of the way Rust works and thinks, and to like some extent it was I think the real tipping point of why we chose Rust over say C++. Is because the philosophy of having a really good type system that's very helpful and in many ways I think user-friendly and intuitive, although there are things in Rust that are a bit hard to understand, like traits. Once you are working to get your head around it, then you get it eventually. But I think there are real energy match there between how you think and TypeQL works and what we want it to be, and how Rust works as a community, how it programs, how it developed, its origin stories of going into being a web backend language for a while. And I think it's just so many beautiful parallels. And I think Rust is a beautiful language, objectively in many ways, with matches and memory management as part of the type system. It's very. I know that a lot of the ideas where Rust came from existed in academia and in other languages, and it's a very nice amalgamation of them. And yeah, I just think Rust is an awesome language overall. It's very, and that's why it has such a big following. And I want to give a little shout out to the Rust New York City community because I've been there to give a talk, and also they've been very welcoming and are really well organized, and it's showing the enthusiasm that one of the first communities to really start growing post-COVID has been the Rust community, where I'm living in New York. So it's been really interesting to see the enthusiasm, and that's what we also feel for us and what we're building.
Yeah. I think the bit that kind of like caught me, I felt being too implicit in Rust was when I had to deal with the async stuff. They're doing a lot of changes around the area, things that weren't possible, such as async trait is now made possible. But I had to basically deal a lot with that. not realizing when a variable was implicitly passed into a closure and the ownership.
And I think there's a whole interesting thing to look at in Rust, because as far as I understand it, and maybe I should be fact checked before I talk about it too much, but I understand that like Rust almost in my mind almost like wasn't necessarily willing to or prematurely added async, because in many ways the mental model of Rust is so much for a stack-based system. And async is not a stack-based system the way they implemented it and the way they wanted it to be not costly as an abstraction. So they ended up with the state machine and everything is pre-allocated and you're jumping between states, and async is execution is hidden from you, but then there's this awkwardness of there's no built-in runtime and that all the lifetime issues and traits don't really work. So it felt like it was an add-on to the language. Yeah. And like when I read about it, at least, and this may be completely wrong, so I hope I don't get cancelled for it. But but I understood it was added to serve the web, the server backend market, and that's what helped Rust survive, because they found adoption there.
Interesting.
And so it's kind of like this interesting like space of when we're designing our language as well, is like you can have this philosophy and then there's the pragmatism. And living in that trade-off land as an entity that has to survive, it's very interesting. And I think that's probably worth a whole separate discussion at some point. But I just think we've learned a lot from going from Java to Rust and learning the philosophy and understanding the synergies with our language. I think you've learned a lot about Rust and program analysis and structure. And as a company, we really value thinking about those things and designing well, ultimately.
Yeah. All right. We've covered a lot.
There's just so much to talk about here. I think we need to wind down.
We could go.
2 hours later.
Not going to get any worse out today.
People are knocking on the door.
Anything
if
else?
we want to do this again, we can talk about Kotlin, because that's another one we've used as an evolution of Java, but a little teaser there.
Yeah, I think it's good to kind of like scope the discussion. Now that I think about it, like before we were thinking of including that, but I think it's just focus on Java and Rust.
Yeah.
All right. Anything else to add, guys? I think it's been quite.
That's been
That's
fun.
been great.
Yeah. Awesome.
Finally, like sometimes you do get to talk about the things.
The technical things.
Yep.
We like talking about everything.
Yeah. All right, guys. I think that's it for today. And I'll see you guys soonish.
Whenever we do it next.
Josh. Yeah, whenever we do it next.
And I might be remote next time.
Yep. It's Josh. Thank you, James, and me myself.
And I.
All right. See ya, guys.